a mass is raised vertically, and in time t, the increase in gravitational potential energy is EP, okay, and the increase in kinetic energy is EK, and we need to compute what is the average power input to the mass, right? So remember, the power is equals to the change, the delta E, change in energy per unit time, okay? That's the definition of watt, right? Joules per second. If we check the unit of power, that is joules per coulomb, right? This is the amount of energy entered into the system, or it was released by the system, right? But this time we are actually increasing the potential energy and increasing the kinetic energy. So we can say that we are actually putting the energy to the system, and the system is represented by the mass, right? So we can say that the total change in energy is equals to EK plus EP, right? Because it is mentioned in the question that gravitational potential energy is changed by this much, and the kinetic energy is changed by this much. So we know that the total change is EK plus EP, right? And in what time it is done, in what time? So we know the value of time. It is given, this is in time t, right? So we can divide it by t to calculate the rate of change of energy. And rate of change of energy is represented by power, right? Power is the amount of the energy converted, or energy converted per unit time. So we can say that the correct option is option D.